The fully automatic induction hexagonal bar end heating system by Duolin is designed for precise, efficient heating of hexagonal steel bar ends, commonly used in fastener and forging industries. It integrates automatic feeding, positioning, and heating processes to ensure consistent temperature control and minimal energy loss. With programmable settings and real-time monitoring, this solution increases production efficiency, reduces labor costs, and delivers uniform heating quality suitable for high-volume manufacturing environments. Duolin's carbon steel round bar full heating system provides uniform through heating of round bars for forging or forming applications. It ensures deep, consistent heat penetration, ideal for high-efficiency production lines requiring precise temperature control and fast heating cycles. The automatic steel plate induction heating system by Duolin delivers rapid, uniform surface heating for steel plates, ideal for bending, forming, or heat treatment. It features automated loading and unloading, precise temperature control, and energy-efficient operation for continuous production. Duolin's CNC induction roller hardening machine offers precise surface hardening for industrial rollers using advanced CNC control. It ensures uniform hardness, accurate heating zones, and consistent depth with real-time monitoring. Ideal for manufacturing and repair, it enhances roller durability, wear resistance, and extends service life with minimal distortion. The gear teeth induction heating for hardening machine by Duolin delivers targeted, rapid heating to gear teeth, ensuring uniform hardness and wear resistance. It supports precise positioning, controlled heating depth, and minimal deformation, ideal for automotive, machinery, and gear manufacturing industries. Duolin's shaft surface induction hardening system is designed for high-precision hardening of various shaft components used in automotive, aerospace, and machinery industries. The process involves rapid surface heating followed by controlled quenching, creating a hardened layer with excellent wear resistance while maintaining a tough core. With CNC or PLC control, the system ensures accurate positioning, consistent hardness depth, and uniform heat distribution along the shaft. It is suitable for processing shafts of different lengths and diameters, improving fatigue strength, durability, and service life without compromising dimensional stability or structural integrity. Duolin's saw blade induction brazing and welding ensures precise, strong tooth attachment with fast, clean, and energy-efficient heating. Efficient, precise rotor joint bonding with localized induction brazing. Heavy-duty engine crankshaft forging involves heating high-grade steel billets to forging temperature and shaping them using precision dies. This process forms the crankshaft's complex geometry while refining the grain structure. The forging enhances mechanical strength, fatigue resistance, and durability, crucial for withstanding the extreme stresses found in large industrial and automotive engines. Forge rolling operation is a crucial pre-forging process where a heated steel billet is passed through rotating rolls to gradually reduce its cross-section and elongate its shape. This operation helps align the grain flow along the crankshaft's axis, significantly improving its mechanical properties such as strength and fatigue resistance. It also ensures a more uniform distribution of material, reduces internal defects, and prepares the billet for subsequent precision forging. By optimizing material usage and minimizing flash formation, forge rolling enhances efficiency and contributes to producing high-quality forged crankshafts with superior structural integrity. The 12,800-ton screw press is a high-capacity forging machine used to form crankshafts with exceptional force and precision. Utilizing rotational energy converted into linear motion, it delivers rapid, controlled impacts that shape the hot billet into its final geometry. This press ensures excellent dimensional accuracy, improved internal structure, and high-density parts essential for heavy-duty engine crankshafts. The 2,500-ton hydraulic trimming and calibration operation is a post-forging process designed to refine the forged crankshaft. After the initial forging, excess material or flash formed along the parting lines is removed using a high-pressure hydraulic trimming press. This ensures clean edges and accurate profiles. Following trimming, the crankshaft undergoes calibration, where controlled hydraulic force is applied to restore dimensional precision, correct slight distortions, and meet strict tolerances. This step is essential to ensure consistency in mass production and to prepare the crankshaft for subsequent machining. The use of hydraulic systems offers superior control, repeatability, and minimal impact stress, helping maintain the integrity of the forged component. Controlled cooling ensures uniform grain structure and prevents thermal cracking. Automated warm straightening corrects deformation with precise thermal control. Ply cutting and kitting involves precision cutting of composite materials into predefined shapes and sizes, followed by organized grouping, kitting, to ensure efficient layup and traceability during wing skin fabrication. Skin layup is the process of meticulously layering pre-cut composite plies onto a mold to form the wing skin's shape. Technicians or automated systems align each ply for optimal strength, ensuring accuracy, fiber orientation, and structural integrity. Wing skin preforming shapes layered composites into aerodynamic contours. Robotic systems accurately place stringers to reinforce wing structure. Resin is infused into composites, then cured for structural strength. This process enables production of large, integrated composite structures, minimizing joints and fasteners. It leads to material savings, faster manufacturing cycles, lighter components, and lower inspection and maintenance requirements over the aircraft's life cycle. 5-axis machining enables precise cutting of complex wing components by moving tools along 5 axes, ensuring high accuracy and optimal aerodynamics. Non-destructive testing, NDT, inspects composite parts for internal flaws using ultrasound or X-ray, ensuring structural integrity without damaging components. Protective coatings are applied for durability, appearance, and identification. During jig load, wing components are precisely positioned in assembly jigs to ensure accurate alignment and structural consistency during build. The torque box, a primary structural component, is assembled by joining upper and lower wing skins with spars and ribs for strength. Automated drilling uses high-precision robotic systems to create consistent, accurate holes for fasteners. This enhances build quality, reduces human error, increases throughput, and ensures structural integrity of wing assemblies. Fastener installation secures wing components using automated or manual systems to insert and tighten bolts, rivets, or specialty fasteners. This ensures structural strength, alignment accuracy, and long-term durability of the assembly. Jig exit marks the transition point where the assembled wing structure is removed from the tooling jig. At this stage, the wing is structurally complete and ready for final system installations. Final components and systems are added before wing line integration. The pulse line is a synchronized, station-based production system where wing assemblies move through sequential stages at fixed intervals. Each station performs specific tasks, such as system installation, inspection, or testing, before the wing advances. This lean manufacturing approach enhances efficiency, reduces downtime, and ensures consistent quality. It allows for streamlined workflow, improved traceability, and faster overall production cycles. Hot forging is a key manufacturing process at United Forge Industries involving the shaping of metal at high temperatures, typically above 1,100 degrees Celsius for steel. This temperature range improves the metal's ductility and reduces its resistance to deformation, allowing it to be molded with precision using dies and hammers. Our advanced hot forging unit ensures uniform grain structure, enhanced strength, and superior mechanical properties. It is ideal for producing durable pipe fittings and flanges used in high-pressure and high-temperature industrial applications. Machining finishing ensures precise dimensions, smooth surfaces, and tight tolerances, enhancing product performance and meeting strict industry standards. Butt weld fittings are pipe fittings welded directly to the piping system for a strong, leak-proof connection. They offer smooth flow, high strength, and are ideal for high-pressure applications. An induction bending machine uses electromagnetic induction to heat and bend pipes with precision. It enables smooth, controlled bends without wrinkles or thinning, ideal for complex and high-stress piping systems. Shot blasting is a surface treatment process that propels abrasive material at high velocity to clean, strengthen, or polish metal surfaces, ensuring superior finish, improved coating adhesion, and corrosion resistance. Hydro testing involves filling pipe fittings or systems with water and pressurizing them to check for leaks, strength, and durability, ensuring they meet safety and performance standards before deployment. The new high-powered CNC multi-purpose machine from Rottler represents a significant leap forward in precision machining technology. Designed for a wide range of automotive and industrial applications, this advanced equipment combines high-speed performance with unmatched accuracy. Its powerful spindle, robust construction, and intuitive CNC control system enable users to perform complex tasks such as cylinder boring, line boring, surface milling, and the installation of sleeves and bushings, all with minimal setup time. One of the standout features of the Rottler CNC machine is its ability to drastically reduce machining time while maintaining exceptional surface quality and dimensional accuracy. This makes it ideal for engine rebuilding, component repair, and custom manufacturing. The machine is also equipped with a versatile range of tooling and programmable options, allowing it to adapt to various job requirements with ease. With expanded capabilities and smart automation features, the Rottler CNC multi-purpose machine helps workshops increase productivity, reduce manual labor, and ensure consistent, high-quality results. Whether you're dealing with small engines or large industrial components, this machine delivers the performance and reliability professionals demand. It's not just a machine, it's a complete solution for modern precision machining. The GT 3 to 8 wire straightening and cutting machine is designed for processing cold rolled, ribbed, and round steel wires, with diameters ranging from 3 mm to 8 mm. It offers high precision straightening and accurate cutting, ensuring optimal performance for mesh welding lines. The line wire payoffs and line wire feeder ensure smooth, consistent feeding of longitudinal wires into the welding line. Designed for high-speed operation, they maintain wire tension and alignment, minimizing downtime and ensuring precise placement for accurate mesh welding. The crosswire feeder automatically positions and feeds transverse wires with precision, ensuring accurate placement for consistent and efficient welding. The main welding machine utilizes advanced pneumatic technology to deliver strong, uniform welds with high speed, accuracy, and energy efficiency. User-friendly interface for real-time control, monitoring, and adjustments. The innovative mesh linear pull-out system ensures a smooth, continuous withdrawal of welded mesh. It precisely aligns, maintains tension, and minimizes manual handling, streamlining production, and enhancing overall workflow efficiency. The automatic mesh falling device collects finished mesh panels by automatically dropping them into a stacking area. It reduces manual labor, increases efficiency, and ensures consistent handling of welded mesh sheets. The automatic mesh falling device transport enhances workflow by not only collecting finished mesh panels but also transporting them to the designated stacking or packaging area. This system ensures seamless, hands-free operation, reduces labor intensity, and improves production efficiency by integrating collection and transport into a single automated process. Innovative 3D modeling, rapid prototyping, and rigorous in-house testing processes. Advanced simulation techniques, including stress, thermal, and fatigue analysis, ensure optimal performance, durability, and safety of every component design. At Mahindra Sona Limited, testing is a critical phase in our product development cycle. Every component undergoes rigorous validation to ensure it meets international quality and performance standards. Our in-house testing facilities are equipped with advanced instruments for endurance testing, fatigue analysis, vibration testing, torque measurement, and dimensional accuracy checks. Environmental testing is also conducted to evaluate component performance under extreme temperature and humidity conditions. Each test simulates real-world operating conditions to ensure reliability and durability. By integrating testing early in the development process, we minimize failures, reduce lead times, and ensure customer satisfaction through consistently high-quality, dependable automotive components. Quality testing at Mahindra Sona Limited involves multi-stage inspections using precision instruments, ensuring dimensional accuracy, material integrity, and performance consistency. Automated systems and manual checks verify compliance with international standards, guaranteeing reliable, high-performance automotive components for global markets. The UBF112N is a high-performance CNC double-saddle lathe designed specifically for the reprofiling of wheel sets used in rail vehicles. It is also well-suited for machining newly manufactured wheel sets or those fitted with new tires. This special-purpose lathe accommodates wheel sets that may include axle boxes on external journals, gear assemblies positioned between the wheels, and brake discs, making it highly versatile for a wide range of railway applications. The UBF112N incorporates an advanced CNC control system, which, combined with automatic measurement capabilities, ensures precise, economical, and efficient machining. The integrated measurement system allows the machine to assess the wheel profiles in real time, adjusting cutting parameters as needed to maintain accuracy throughout the process. One of the key strengths of the UBF 112N is its flexibility. Its universal tooling setup and extensive programming capabilities allow quick adaptation to different wheel profiles without the need for physical modifications or retooling. This reduces downtime and enhances the machine's ability to handle both standard and non-standard wheel configurations. Operation of the UBF 112N is user-friendly and streamlined. The control system is designed for single-operator use and features a graphical interface that guides the operator through each stage of the machining process. Additionally, the system includes diagnostic tools that monitor the lathe's status, detect any malfunctions, and suggest corrective measures to minimize disruptions.